The next topic, reflective surfaces. Or on our light probe, specular reflections. And we'll begin with the topic of placing the highlight. So many art books and many resources online, they are confusing the highlight with the center light. And I think that's not accurate. So what do I mean? Here is the highlight. That's the reflection of the light source actually on your object. The center light is that part of the object where the surface is pointing towards the light source most directly. On this cylinder, the center light is up here on the top. This is where the plane of the surface is facing towards the light. On this sculpture, the center light would be in this region. But it's actually not the same place as the highlight. In fact, the two can never be in the same position. There's only one exception where they can, and I'll show you in a moment. Here's a planar sphere and a light. So I'm going to move the light around, and you can see both the center light and the highlight kind of moving, traveling on the surface. If we go to a top view, you can see the lamp and the sphere again. Let's visualize the light rays coming from this lamp. So they're fanning out and they're hitting our sphere at different angles. This area I would call the center light. It's not clearly mathematically defined, but I would say it's the planes that face most directly towards the light source. The light ray that hits that center plane is going to be reflected straight back. The light ray that hits this plane is coming in at a certain angle and it's going to be reflected at that same angle. So it's the next plane where the light ray is coming in and is being reflected off, and that light traveling from the lamp is hitting our eye. So this is where we see the highlight. From the 3D view again, center light is over there and highlight is this plane here. So they're not the same. Let's build some intuition muscles about this. So here again is a light, a camera, and a sphere. I'm going to move the light around, and on the left side of the screen you can see what the camera sees. So as I'm moving the light around the sphere here, you can see the light direction change in the camera view. Now your job is to place the highlight on that sphere. You can actually do it with your finger or with a pencil or a tool. Touch the screen where you think the highlight is. The highlight is exactly in the center. This would be if the camera is looking from the same position as the light. This is the only case, the only exception where center light and highlight are in the same position. Now let me move the light 90 degrees to the left and make another guess. I think you might be surprised where the highlight ends up, but make a guess. Again, hold your finger or a tool up to the screen where you think the highlight would be seen from where the camera is. It's right there. So my guess, my intuitive sense would be that if the light is coming from the side, the highlight would be somewhere here. But it's not. It's more to the left than I would have thought. So I'm showing you this so you can kind of build your intuition. And if you know that the light is coming straight from the side, you know that the highlight has to be a little bit further to the left than you might have estimated. Let's bring the light forward to 45 degrees. And again, make an estimation of where you think the highlight will be now. And I'm revealing it's here. Again, I'm a little bit surprised because I would think it's closer to the center. So just take note of this and maybe run through this again in the future. Now here's a tricky one. I'm moving the light back kind of 45 degrees from behind. Make your guess Here it is. It's actually still visible. And you can see that if you trace the light ray from the light source bouncing off of the surface into the camera. So as long as you can see the form light, you will see a highlight as well. And just in the interest of being complete, if we move the light all the way back, of course, there's nothing, there's no highlight, there's no form light. All we're seeing now is form shadow. And in this case, actually the silhouette of the sphere is identical with the Terminator. But we're just looking at the shadow side of this sphere. Next, more practice. You can see the chrome ball on the right and a shell on the left. On the chrome ball, you can also see the highlight. Take a look at the direction of the cast shadow and how it relates to the position of the highlight. The cast shadow is always aligned with the light direction. The light direction is aligned with the minor axis of the Terminator ellipse. And this is the fun trick, the highlight sits on that same line. Always. This is super helpful to estimate the highlight position. So in this image I edited out the highlight and I'm going to reveal it in a moment. But again, make an estimation. Look at this scene in general. Where are the shadows? Well, there are no shadows. That can only mean one thing. Place the highlight with your finger or a tool. Exactly in the middle. So this is that one exception where we are looking from the light direction. And the highlight is right in the center. Good job if you got this one right. Now, what about this one? You can see the light is coming from the top left, so you can make an estimation about where to place the highlight. Ready? It's here. Next, let's go a bit faster. Place it. It is here. Now compare this to the next one. The light is closer to the floor. That has a consequence on the position of the highlight. You can see the cast shadow is also longer, so those two things together should tell you something about where to place the highlight. So make a guess now. It is here, closer to the edge. Finally, I threw this image in just for fun. I turned off the light in the room here, so the only light that's coming in is ambient light from the two windows. You can see them in the sphere. So as a result, the only shading we have on the shell is ambient occlusion. This is a nice example of ambient occlusion in the wild. And one more example. Here the shell and the sphere are underneath the car, and you can see the reflected light from the floor. A warm light hitting the front of the shell and also being reflected in the chrome ball. If you look at the top of the chrome ball, you can see a sliver of that orange bright light again. That's actually the other side of the shadow underneath the car. It's pretty cool. Then on the shell, you see that blue light. That's the skylight, the influence of the blue ambient light. And you can see that clearly on the chrome ball as well. Now let's put this into practice.